Okay, welcome Sarah and Maya and Chin Mary. Thanks for coming. Hopefully we'll get a few more. Let me share my desktop and talk about the plan today. Okay, so as usual, I'll start out with any questions that anyone might have. And then we're moving on to focusing on on quantitative variables. So we're going to be looking at least we're going to start with quantitative variables. We're going to remind you the difference between a discrete and a continuous variable. So that happened a while back, a few weeks, the beginning of the class, and now we're going to come back to it. And then we're going to focus on discrete variables and talk about probability distribution tables. And then look at the expected value and standard deviation for a discrete variable. Then we'll talk about the binomial distribution. So that's going to be if you do a survey with a yes/no question, you want to find probabilities based on it. Then we'll move from discrete variables to continuous variables. Okay, so you can't do all of the continuous variables today. I'll just give you an idea of general, and then we're going to focus on one. Not because it's the most important, but because it's the easiest. And that's called the uniform distribution. So we'll look at the uniform distribution. We'll have an example or two on using the uniform distribution, getting probabilities and percentiles. And then after that, we'll get into the mean and the standard deviation of a uniform distribution and using those. So that is the plan for today. I want to remind you about a couple things. One is that you should be making lots of progress on your project now. And I know I saw in the project discussion board, there's one student looking for a partner. So if there's only two of you, maybe you can reply to that and say, hey, join us. Then you'll have less work to do because that person will contribute. So it's always better to have 3 than 2. And if you're alone, by the way, if you don't have a partner, then you should immediately see if that person can be your partners because you need a partner. So that's, absolute priority right now is to make sure that you're well on your way into that project. Some of you have already posted your ideas for the project, and that's great. Those of you who haven't yet, that should be done too. Post your ideas on the project discussion board so that I can help you, let you know what works. You can also look at other people's posts to see what works and what needs to be modified so that you have good ideas. So that's just what's coming up, and not too much longer, end of month or beginning of next month, something like that, is the project will be due. So are there any questions about anything from the class or the assignments or anything else? Any questions? Give you a second. Okay, and I do want to remind you, if you ever want an extension from your assignments, for non-discussion assignments, they need to be asked for by Friday before they're due. Don't wait till after the due date happened and then ask, because the answer is always no. So ask on the Friday before they're due, and then I always say yes, but I want you to be working on it during the week instead of waiting until the last minute, and then realizing that at that last minute you ran out of time and you couldn't do it. But if you're working on it, all the way up to Friday, you realize, oh, it's this isn't going to work out, then talk to me, then send me an email. So just a note, I got a couple of those emails, and so I'll let you know you have to ask early for the extension. Any questions? Any questions at all? Okay, if there's no questions, then I'll move on to the new material. I want to mention.
Larry.
Yeah.
Yes. So I was thinking, like if for exam, I would want to go back and do all of the chapter exercises, but I was wondering how would I get the answers to those exercises so that I could know if I was doing it right or wrong?
So you mean like the chapter 3 exercises that you just did on that you finished up last week, something like
Yes.
that. So the answers show up after you try.
Oh, okay. Okay, sorry.
Yeah. So
Didn't know.
there's a little icon. It's kind of a little circle with a line along it. And you click on that and it gives you the answer.
Okay, great. Thank you.
Have you seen that before?
Yes. I think I just haven't done a lot of them. So I wanted to, before the exam, to go back and do them so that I remember them.
Yeah. So the answers should all show up. And again, you can work on any of the exercises in what's called review mode. You don't get points, but you get learning, and learning is the most important thing.
Oh, okay. Okay,
working.
that's good to know. Thank you.
Yeah, and you don't lose points if you get them wrong or anything. That's the good news. Yeah, so those are up. Those are definitely open to try and practice. Okay. And also I want to remind you that all these webinars are on YouTube. So all the examples that I give in class, those are also available, because those are even better because those have a lot of writing involved, and that's what the test is going to have. So what I recommend is going back to the video, watch me propose the question, hit pause, try it yourself, and then you get the answer, because then you hit record, hit play, and then you get to see me answer it. So that's actually a really good way of studying for the test, is to try that. And we'll be doing more of those today. Okay, so I always give examples. So hopefully that helps out. Okay, any other questions? Okay, so now let's see if you remember. If you don't, that's okay. It's been 2 weeks already. And that is, what is the difference between a discrete and a continuous variable? You remember. Happened 2 weeks ago. I don't see y'all jumping in.
A discrete has an infinite amount of numbers.
It's kind of backwards. So continuous has the infinite. You got the right idea, you were just switched. So, and it's a little more than infinite. And I'm not going to get into the details of that, because that involves like higher level math, which, beyond calculus even. But basically it says the way I write it, because I think it's the easiest way for you guys to understand it without like being a math major or something. And that is the discrete variable. First thing, it's quantitative. So discrete variables are quantitative. They're not the yes, no question or what's your favorite color or anything like that. They're number answers. And the set of outcomes can be displayed in a list. Okay, I think that's the best way of saying it. And that means it could be just a list of 10 numbers. It could be a list with a ... but you can write a list. Okay. Quantitative variables that are not discrete are continuous. Okay, so for a discrete variable, you can always write a table of all of the possible outcomes. Sometimes you'll need ... but usually not. All of the possible outcomes and their corresponding probabilities. Okay, so that is what we're going to be working with, is a discrete variable. You can always create a table. Whereas with a continuous variable, you can never create a table. Okay, because you just can't list them all. So if I asked you, survey question was, how much do you weigh? Exactly. You can't list all of the different possibilities. Do you remember that? Whereas with how much you weigh, whereas something like how many hats do you own? That you can list all the possibilities. You have 0 or 1 or 2. You can go all the way up to 1,000,000 or something, and that's it. No one owns more than that. If they do, you could always put ... Okay, and then you could put the probability of someone wearing 2 hats or 5 hats or 12 hats. All the different lists you can find probabilities of, at least in theory. Any questions on the idea of what especially a discrete variable is? Okay, so here is an example. And that is the following. A car salesperson gives out a $10 gift to every customer who test drives a car. Okay. That sometimes happens. They'll have an advertisement. Hey, come in, you get $10 if you test drive our car. You know, they're hoping you buy it, right? 12% of all customers who test drive a car purchase the base model of the car, resulting in a $200 commission for the salesperson. 8% of all customers who test drive a car purchase the deluxe model of the car, resulting in a $300 commission for the salesperson. So what we're looking at is profit. Is this a discrete variable? Is the profit a discrete variable for this example? What do you think? Yes or no?
Yes.
Yeah, this is a discrete variable because there are only 3 different things that could happen. And all 3 result in a number. Profit is always a number, right? So this is definitely a discrete variable. Any questions on that idea? So when you have a discrete variable, we can create a probability distribution table. So what I'm going to do is I'm going to make a table. And on the table, I'm going to have 2 rows. Sometimes you do rows, sometimes you do columns. It doesn't matter, but rows are a little easier for this particular example. And I'm going to label the first one X, and the second row will be P of X. What do you think P of X represents? What does that mean?
Probability of X.
Yeah, the probability of a value of X occurring. Okay. So what we need to do next is we need to come up with the different possible values of X. And this is discrete, which means we can do it, right? So let's look at it. Well, one thing is it's possible that they purchase a base model. What's the profit if they purchase a base model? What's the profit if they purchase a base model? It's not a trick question. But you have to know what profit means.
Profit of the car or the commission?
It's the profit for the salesperson. You could assume the salesperson owns the whole company, and then you don't have to get into details, weird details. Yeah, cars don't make anything. They're just like objects. It's the salesperson that's making money. So the commission, it says, the commission is $200. Right? So the commission is $200. So what do you think? What's the profit? All right. Do you know what profit means?
I feel like we don't have enough information to determine the profit of the car.
Yeah, we have enough information. Okay, so profit, if you don't know, is revenue minus cost. How much you make minus how much you had to spend. How much is the salesperson making in commission?
200.
And how much is the salesperson spending? Hint, read the first sentence.
$10.
$10. So what's the profit?
190.
190. Any questions on that? The profit is the 200 that you're making minus the $10 that you have to give away. So that's going to be 190. Any questions on finding the profit for the base model outcome? Okay, what about the deluxe model outcome? What's the profit for the deluxe model outcome?
300.
Okay, remember profit is revenue minus cost.
290.
290.
Yeah. You're going to take 300 and you're going to subtract 10. And when you do that, you get 290. Any questions on that? Is there anything else that could happen? Or is that everything?
They could not test drive a car.
Yeah, or more importantly, not test drive. It's not something else though.
Not buy the car.
Not buy the car, not buy any car. Right? If they don't test drive it, they're not even included in the study. Right? You know, I'm not included. I'm not going into looking for a car in the next year or two. It's not my interest right now. My car's fine. So people like me don't count. It's the only ones that count are your customers. So if they don't buy the car, what is the profit?
Minus $10.
Yeah, it's minus 10 because your revenue is 0 and your cost is still 10. 0 minus 10 is negative 10. Any questions at all? Any questions at all on finding the X values for the probability distribution table for this example? Okay, so now I need to find P of X. Shouldn't be too hard. What's the probability of a profit of $190? The hint is it's given in the problem.
12%.
Yeah, 12%. It's better to write that as a decimal because no calculators like percents. They like decimals. So how do you write that as a decimal? 0 point. So what's the probability?
.12.
Yeah, 0.12. So remember, if you have a percent, you move the decimal over 2 places, and that gives you your decimal. What's the probability of a profit of $290?
0.08.
Yeah, 0.08. Okay, now the next one's a little harder, but not that bad. How do we find the probability of not selling the car or a car? So how do we find that third probability?
Add up the percentages and subtract them from 100.
Yeah, exactly. So if you have 12% of the base model, 8% for the deluxe model, 12% plus 8% is 20%. So that means a 20% chance they're going to buy something. So what percent chance are they not going to buy something?
80%.
80%, and we got to write that as a decimal, which is? So what is it as a decimal?
0.80.
Yeah, 0.80. And there's our probability distribution table. Any questions on taking this paragraph, reading it first, identifying that it is a discrete distribution question, and then second is coming up with the probability distribution table. All right, so one of the things, think about now you're in business, right? Is this a job you want to take or not? What does it mean that it's a good job? What would a horrible job be?
That it's like highly profitable.
Yeah, you better make money. Okay. Otherwise you're volunteering for something and losing money on that. That'd be awful. So what we want to do is want to see, well, how much profit are we going to make? Okay. So if you thought about this as a possible job for yourself, okay, or business, if you're going into business, then you want to find out, is this going to work? And there's two things actually. One, is this business going to work? Okay, as in, are you going to make in the long run, are you going to make a profit or are you going to lose money? But there's actually a little more to it, and that's risk. Okay, it's something you may not have thought about, but the word risk in business, what is that word? How is that? What is that word in statistics? It's one of the most important two words we've had in our whole class, where you can talk, where you understand the risk based on it.
Something variables.
Good try. Here's a hint. You got to write a whole paragraph on it on your project.
Standard deviation.
The standard deviation, right? Because if it's a high standard deviation, that means there's risk, because that means that there's a decent chance you're going to be way below what you thought you were going to get. Okay, and the risk might be on the upside too. You might be risking making huge amounts of money. That's good, but the going downside is not so good. Okay, so what we're interested in is what's called the expected value, which is in the long run, what would we expect to make on average? And how risky this is, what is the standard deviation? So let's go ahead and define these two things. So the expected value is the following. If many trials are done, okay? So in this example, if you have many customers come in, that's what a trial is. Every time a customer comes in, that's a trial. So if many customers come in, or if many trials are done, then it is very likely that the average of the trials, so your average profit in this case, will be very close to the expected value. So the idea here, this talks about long-term gains or long-term losses. That could happen too, either way. And that's the expected value. And something, I don't think I've mentioned this before, but it's called the law of large numbers. And that says that in the long run, you're going to get close to whatever that expected value is. Okay. So if you flip a coin 1,000,000 times and it's a, you know, it's a good fair coin, then after a very long time, you're going to be really likely to be close to half heads, half tails. Does that make sense? You're not going to get 3/4 heads and 3/4 tails if it's a fair coin after 1,000,000 tries. Could it happen? Yes, but it's so unlikely that nah. Okay, and that's what the expected value is all about. Okay, now here's something I want you to note. See, I highlighted in red many, likely, average, and close to. Here's a guarantee. On your exam, you're going to be asked to find and interpret an expected value. And if you don't have the word many, the word likely, the word average, and the word close to, what do you think is going to happen to you? On your exam. So in your interpretation, if you don't have those words, what's going to happen?
Lose points.
Exactly, you're going to lose points. My guess is you don't want to lose points. So here it is, I'm promising you. So something to note, you know, it's a few weeks from now, your exam's not tomorrow or anything, but when you're studying for that exam, since the first question of the quarter about studying for the exam happened today, thank you. And when you're studying for the exam, make sure that you have that down. You can put it on a note card, whatever it takes. When you're talking about expected value, you need to have those words, because that's what expected value is about. And with those words, that'll guide you. Okay, the next line is the formula. which we're not going to use so much because the calculator I wrote does it for you. But I want to mention it and kind of tell you what's going on. First thing is that you'll often see two different notations for expected value. The first one is probably obvious to all of you. Why do you think EV? And don't tell me electric vehicle.
Expected value.
Yeah, it stands for expected value. So we use EV. By the way, EV came for expected value way before electric vehicles were around. Okay. And then it's also mu. What's mu correspond to that you've already learned, in the last few weeks?
The mean?
The mean. The expected value is a mean. We'll check it out. That's one of our highlighted words, average. Average and mean are basically the same thing. So the expected value is the mean. It's your long-term mean. Any questions on that?
I have a question.
Mm-hmm.
So anytime you see the mu in any kind of math, that refers to the mean?
Not quite, but any statistics.
Okay.
Math is a very broad topic. So if it's nothing to do with statistics, sometimes you'll see mu for other things. I'm not going to get involved in it. But in this class, we'll never use mu for anything other than mean. If you go fly to Athens, you'll see mu all the time for other things, right? Because it's a Greek letter. It's just, he'll be everywhere. And it'll have nothing to do with the mean. Okay, but I don't speak Greek, so I don't know. I can't even give an example. But you get the idea? So mu is used for other things, but in our class, in statistics, okay, and even advanced statistics, I don't think I've ever seen mu used for anything other than population mean. So hopefully that answers your question. But general math is different. There's just too much going on, so you got to use every letter multiple times. Okay, I guess if we use Chinese, we'd be okay because they have like 20,000 letters or something. I've learned a lot of those letters. It's hard. Greek is easier, trust me. Okay, so the formula, which you're not responsible for, but I should put it here, it means add up all the x times p of x. Okay, don't do that by hand. You don't need to in this class, but that's going to be that's the formula for the expected value. Any questions on the expected value? All right, so now the question I have is find the expected value and standard deviation for the car salesperson example. Interpret the expected value, and is this a lucrative job? Okay, and maybe I should also write, how should you react? The salesperson react to the standard deviation. Okay, so let me, just to make it a little easier, I'm going to copy and paste this table. Come on, try again. There we go. So that we have it right here. So we need to find the expected value and we need to find the standard deviation. Any questions on the question? So I better write this down because I'm going to leave the screen in a minute. So we have 190, 290, negative 10, 0.12, 0.08, 0.8. All right, so what I need to do now is I need to go to the calculator. And I'm hoping you can tell me which calculator number I'm going to be using. I tried to make this easy.
6.
It's 6. Okay. By the way, anytime you have any suggestions, like rewording something or whatever, let me know. I'll reword it, if it makes sense. So I click on the number 6. And it asks you to complete the table. So let's just redo the table. And x again, 190. Our p of x was 0.12. Our next x was 290. Our next p of x was 0.08. Our next x was -10. And the p of x was 0.8. Any questions? Any questions? Okay. And note, by the way, if you happen to have very large numbers, I put this in because last quarter people had trouble and I said, I better write that down. So if you had, 570,231, don't put a comma in when you're writing the number. Just leave it as only digits. Does that make sense? Because the computer doesn't like commas for numbers. All right, so then I scroll and I just hit calculate. So there's our expected value and standard deviation. The expected value is 38 and standard deviation, I'll just round to the nearest whole number, and that's 98. This is dollars. Maybe you care about pennies, but at this kind of rate, rounding to the nearest dollar, I think makes the most sense. Okay, if you're doing the assignment online, then you do whatever it tells you to do. If it says 4 decimals, do 4 decimals. Okay, whatever it asks is what you should do. Any questions at all on finding the expected value and finding the standard deviation? All right, so our expected value was equal to 38. So now it's time to interpret it. Okay, and the idea here is we can say if the car salesperson has many customers, then it is likely that the salesperson average profit per customer will be close to, and the units are dollars, $38. Any questions on this idea here? Just notice how many times is he going to make $38 for a particular customer?
Never.
Exactly, never. 190, 290, and -10 are the only things that could happen. The expected value does not tell you a likely outcome. The expected value tells you in the long run what the average is likely to be close to. It's very different than just saying, it's going to make $30. That's $38. That's not true. Okay. It means in the long run. So if this salesperson's working for a few years, having some customers every day, now the average profit will be $38. Okay, or close to, not exactly 38, but it's very likely to be close to $38 per customer. So is this a good job? How long do you think it takes to do a test drive with a customer and then haggle?
How do you know like how many customers he has to test drive before he reached that 38?
Okay, so that's a really good question. And here's the bad news is you need to take graduate level statistics to learn about that.
Okay, never mind.
Okay, so yeah, there is ways of actually formulating what the word likely is and what the word close to and many and all that. It's way beyond this class. Do you agree with me? I mean, do you believe me at least? Not agree, but do you agree? Believe me?
Yes, I believe you. You don't need to know.
Yeah, I did learn this once. Okay, and I had to learn it, but that was in a graduate level course at UCLA, so very different. All you have to understand is kind of the idea. Does that make sense? Okay, first thing, is this a profitable adventure? Right? Would you recommend this job? Does it make money? Okay, in the long run, it makes money, right? Okay, I'm not sure. I've never been a car salesperson. My brother was, but I wasn't. So I don't really know how long it takes to show someone a car. But let's say it takes a half an hour. Again, I don't know, but let's say it takes a half an hour per customer. Then the person's making, on average, over the long run, likely to make close to about $76 an hour. Pretty darn good for a job that doesn't require an education. That'd be a great job. Okay. And again, it's guesswork on how long it takes. I have no idea. Okay. And I made these numbers up, by the way, so don't quote me on them. Okay. The standard deviation is $98. What does that mean? What does that tell you? Is it a high standard deviation or low? Look at the mean. That's one hint, or the expected value. What do you think?
Isn't the standard deviation like the spread of
Yep.
the profit versus
Mhm.
like the high end of it versus the low end? So if it's like more than twice what the mean is, it's kind of really high.
Exactly. Okay. So this is a high standard deviation. So in particular, here's what I recommend to the person who's getting this job. So make sure that the person, the salesperson, has pretty much money in their bank account. Since there will be good days and bad days. Even some where the person loses money. Okay, so this is not like my job. My job, I know exactly what I'm getting at the end of the month because I work for the government, because I teach. But salespeople are different. Okay, and this is very typical of salespeople. They work on commission. They have good days and bad days. Any questions on this idea? Okay, all right. I only have time for one example each because we have a lot of things to talk about today. What we don't have to talk about, we're not going to spend time on the project or exams or anything, but I want to get into the next piece of chapter 4, and that is binomial distribution. And here's the definition. A binomial distribution comes from multiple independent trials of a yes-no question and measures the number of yes answers. So very important when you're doing a survey and the answer is yes or no, then we're talking binomial. So here's an example of binomial. All right, so as of today, and by the way, I got this about 10 minutes before class started, LA Times, 42%, okay, of all Californians have received at least one dose of the COVID-19 vaccine, okay? And again, that's combined vaccines. If 15 randomly selected are surveyed, what's the probability that? And then we have a bunch of questions. So first thing, what's the survey question here? It's very simple. What's the survey question for this? Okay. So what is the researcher going to ask people when they go from person to person?
Have you received your first dose of the COVID vaccine?
Exactly. Exactly. And what is the person going to say?
Yes or no?
Yes or no. Okay. By the way, in this class, if you can't get that down, you won't pass this class. You have to be able to differentiate a yes, no question from a quantitative question. Okay. And this is a yes, no question. So this is a really important skill to have for the class, is to be able to look at a question like this and know that this is a yes, no survey question. Because either you got your first dose or you did not get your first dose, right? If the person asked me, I would say yes. I did get my first dose. I got my second too, but I got my first dose. Okay. You can't kind of get your first dose. Okay. You can't answer with a number or any other weird number thing. Either you got it or you didn't. Any questions on that? So that's the first thing, that this is a binomial question, binomial distribution, because we have multiple trials, in this case, 15 trials. So N is 15 here. So we have 15 trials, and at each trial, the result is either yes or no. Okay. Sometimes you'll see success or failure. Those aren't words I like very much, because imagine being a doctor, and the question is, did the patient die? Well, if they say yes, that's success, and that doesn't sound very good. But you'll see statistics. The word yes is also represented with the word success, and the word no is represented with the word failure. Okay, nothing to do whether it's good or bad, by the way. But I want to warn you, when you read the book, you'll see success and failure. I like to use yes and no, because then, it doesn't sound like I'm evil or something when I'm talking about success being dead. Okay, if that makes sense. All right, so here's what we want to do. We want to find the probability that between 5 and 10 of them have received at least one dose. Okay, and by the way, and this is important, if you say, if someone received 5 of the people said yes, then is it true that between 5 and 10 received at least one dose?
Yes.
That's yes. So I want to let you know that between always includes the borders. Okay, and that's important to note. Okay, so there is a lot of mathematics. And do you know what it means if there's a lot of mathematics in terms of what you're responsible for? You're not saying? So let me tell you, you're responsible for none of it. So we don't do a lot of mathematics in this class, but there's a lot of mathematics involved. And this is where you have to trust me. But here's what you are responsible for: using a calculator. Okay, so let's go to the calculator and answer this part A question. So I'm going to go back to the calculator menu. I tried to make it easy. Which one?
Number 7, binomial probability.
Yeah, number 7. And if you noticed, they're ordered in the order we do things. Have you noticed that so far? So I tried to do it that way. I tried to make it as easy as possible for you to be able to figure this stuff out. Okay. Whereas the people in Texas who wrote a TI-84 calculator, they weren't thinking about this class. Just let you know that. They didn't even know about my class when it happened. In fact, I wasn't even teaching then. I think it was like 30 years ago they built it. So I hit binomial probability. What's the low? course, you have to remember. Do you remember in the question?
5.
5. And what's the high?
10.
10. And how many trials were there? If it helps, I'll go back to the screen.
15.
There are 15. And then we have P. What was the probability? P for probability of any individual saying they received it. It's not one of the numbers you're looking at. Here, let me pop this in. So I'll let you read it again. Yeah, 0.42. Any questions on using this calculator? And I hit calculate. And I get 0.8118. So the answer is, let me write the probability that 5 is less than or equal to X is less than or equal to 10 is equal to 0.8118, or about 81% chance. Any questions on this idea so far? Okay, so now what's the probability that at least 7 of them have received at least one dose? Okay, so now let's go back. What's the low for at least 7?
7.
7. What's the high for at least 7?
15.
Yeah, 15. Because you can't have more than 15. If you ask 15 people, you can't get more than 15 yeses. So at least 7, the highest number that could say yes would be 15 for it to be at least 7. And then trials and P are the same. That didn't change in this question. So you calculate again, 0.453. So let's write that down. So the probability that X is greater than or equal to 7 is equal to, and again, that was 0.453, or about 45% chance or so. Okay, what's the probability that less than 9 of them received at least one dose? All right, so let's go back. What's the low for less than 9? What's the smallest number that would satisfy less than 9? Not 1, 0. 0. So 0 is definitely less than 9, and 0 can happen. Okay, not that likely, but it could happen that out of the 15 people you asked, none of them received their first dose. What's the high for less than 9?
8.
8. Yeah, so that's the one you have to be very careful with. 9 is not less than 9, but 8 is. And that's why 8's the highest number that's less than 9. And then trials and P are the same. You calculate, and 8746. So here we can say the probability that oops. Zero is less than or equal to X, less than or equal to 8. was equal to 0.8746, or about 87% chance. Okay, what is the probability that exactly 6 have received at least one dose? What's the low for exactly 6? 6. What's the high for exactly 6?
6.
6 again, right? Because anything other than 6 is not going to work. So it's between 6 and 6. And hit calculate, and I get 2041. So the probability that X is equal to 6 is equal to 0.2041. Or about 20% chance. Any questions on the binomial probability idea? Any questions? Okay, so now we got to move to continuous distributions. So now continuous distributions have an issue. Okay, if you want to compute like the mean or whatever, do stuff with it, you can't just add up all x times p of x, because you can't even list the x's. Okay, in fact, you can't even create a probability distribution table. Okay, you can't do it because you can't list all. So what we do mathematically is we draw a picture instead. So this is an example. And what you do is you draw a picture so that between any 2 points in the picture, if you look at the area under the curve, that's the probability of being between those 2 values. So it's kind of an example. The probability of being between 1.8 and 2.75 is going to be the area between these 2 values. Okay, now, by the way, what's the shape of this curve in one word? Since we've talked about it.
Symmetrical?
It is symmetrical, but you can go more detailed, and particularly a statistics word. It's the most important of all of them. No, normal. I don't know if you remember that word, but normal. So this is a normal distribution. Okay, often called bell-shaped, but this is a normal distribution. And here's the big, horrible issue. Do you know how to find an area under a curve where it looks kind of like this? Okay, the answer is no. Okay, my guess is none of you know how to find the area under a curve that looks like this. Even to giving you the equation of the curve, that's not going to help you. Okay, just let you know, even Braulio doesn't know how to find the exact area under this curve. And he's taken all of the calculus sequences here. But the answer is you can't get it exact. So that's the bad news. The good news is that later on, when we have normal distributions, you'll just use a calculator. And trust the calculator. Okay, and it's intense. That's what I'll tell you. The mathematics is. There is no nice formula you learn in high school that tells you how to find area under a curve. You just don't even. I don't know if you thought about it, but you never went there. There is an area, certainly. You know, if you had to paint this, there's a certain amount of paint you would need to paint this, and that area is the probability. But the math is very difficult. But there is one shape that all of you should know how to find an area of, where you could have a probability distribution curve. Would anyone know what that shape is? Triangle It turns out that I don't expect all of you to know with the triangle, because if you take 2 points, you'll get a trapezoid. And my guess is a lot of you don't remember the area of a formula for a trapezoid. Am I right? Maybe none of you do, but it's a good try. I know how to find the area of a trapezoid. I could do that in my head, but most of you can't. What's the easiest? Yeah, rectangle or square. Okay, we're gonna look at rectangles. So what we're gonna be looking at in this chapter, we're moving to chapter 5, by the way, is we're gonna be looking at a distribution function where we're talking about now rectangles. So let me talk about the example and the definition. So a uniform distribution from A to B is a distribution such that any 2 given intervals of length k that is contained in A to B has the same probability of occurring, and any interval outside of AB has 0 probability. This distribution curve is a rectangle. And the way we write it is the variable is x. And this is something we're going to be doing in the next few chapters. Who knows what this symbol is right here? Not even a math symbol. It's on your computer keyboard. So it's important enough that you don't have to be a math nerd to know about it. You've seen it if you write in Spanish, because then you know ñ. And what I've learned from the Spanish speakers, that they don't have a word for it, but we do. You know another word for that?
Tilde.
Tilde, all right. Somebody knows. Awesome. Yeah, it's called a tilde. So we say x tilde. And in terms of math, what that means is x has the distribution of. Okay, so x's distribution, and hopefully you can tell me what u stands for. Hint, it's in red. So what's u stand for?
Uniform.
Uniform. So we say x has a uniform distribution between A and B. Any questions at all on kind of the idea of a uniform distribution? Any questions? Okay, I think this is best done by example. Okay, there's bad news and good news. Okay, maybe good news and bad news, I should say. The good news is the mathematics of finding these probabilities is easy. Why is that bad news? Because that means you're responsible for it. Instead of just going to a calculator and hit go. You actually have to know how to do it. So let me do an example, and I'll show you what I mean by that. It is easy if you watch me do it. Doing it yourself, that's going to take some practice. Okay, so suppose that the time students spend in the math tutor with a math tutor is uniformly distributed between 10 and 20 minutes. So the first thing, by the way, in symbols, that's x tilde u 10 comma 120. Okay, and I'm making this up. I mean, it probably really isn't uniformly distributed, but it could be. Okay, now, if a randomly selected student who uses a math tutor is observed, find the probability that that student will be spend between 30 and 70 minutes with the tutor. Any questions on the question? All right, so we need to find that probability. And to do that, again, we're going between 10 and 120. We want 30 to 70. So I'm going to draw a picture. And this sometimes works, and I hope it will today. All right, so what I'm going to have is the following. First, I can draw an x-axis. And then I'm going to draw the rectangle. And that rectangle goes from 10 to 120. Okay, then let's label it. And we need to find out what the height is. Let's call that h. Any questions so far? So let me hit save. Okay, so that's the first piece. So one of the things, what is the probability? What's the probability that a randomly selected student will use a tutor between 10 and 120 minutes? And the answer is really easy. If everyone uses between 10 and 120 minutes, what's the probability that someone will use between 10 and 120 minutes? Let me write it. Probability that 10 is less than x, less than 120, is really easy. What is it? If everyone is between 10 and 120, what's the probability that a randomly selected person will be between 10 and 120?
1.
1. Okay, it's not a trick question. It's easy. Do you all agree that was easy? Okay, but we also have that by definition, probability is the area under the curve. Well, area is, for a rectangle, how do you find the area of a rectangle? Who remembers the formula for area of a rectangle? Nothing too fancy. Yeah, base times height. And the base is what? What's the base of this rectangle? How long is it? Yeah, 110. And the height is h. So if 1 equals 110 times h, we could divide by 110 and you get h is equal to 1 over 110. Any questions on the little bit of math? Nothing too intense, but you are responsible for being able to do this. Okay, so now what I'm going to do is now I'm going to draw the picture for the probability that we want, which is between, where is it? Just a minute. Let me save. Between 30 and 70. which is going to be something like that. Any questions on that? So over here, we're going to have 30. And over here, we're going to have 70. So now I can say, what is the probability that 30 is less than x is less than 70? How do I get that? And again, what's the definition of probability for a continuous variable? It's the area under the curve. So it's the shaded in area. How do I find the shaded in area? Again, this is a rectangle. That's a hint. So how do I find the area that's shaded in?
Base times height.
Exactly, base times height. And the base is going to be 70 minus 30. You might be able to do that in your head, but I figure I'd type it out. The height was the same height. We haven't changed that picture. Still 1 over 110. And 70 over 30 is 40. So you get 40 over 110. Okay, and if you want to turn it into decimal, that's up to you. Any questions on finding a probability that involves a uniform distribution? Any questions on that?
How did we find the height again?
Okay, so I know that the area of the whole rectangle has to be 1 because there's a 100% probability of being between 10 and 120. Because those are that's what uniform means, is you can't be left of 10, you can't be right of 120. So then I set 1, which is the area of the whole rectangle, is base times height. And then if you want to find the base, you take 120 minus 10, which was 110, times the height. So we know 110 times h is 1, and we divided both sides by 110. Does that make sense? Or did I lose you somewhere?
So is the height going to be 1 for every rectangle that we do in a problem like this?
No, the height is not 1. The height's 1 over 110.
Oh, so I'm sorry. Yeah, 1 over 100. Okay, I see.
Yeah, so the height does change. Yeah. So if instead of 10 to 120, if it was, let's say 0.5 to 0.6, your height will actually be 10 because your base is 0.1. The area is always 1, exactly. The area of the whole rectangle must always be 1. That's part of probability.
That makes sense.
Any questions? Okay, I just should tell you, this might be the most mathy part of the whole course. Is it feeling mathier? You actually have to solve equations and draw geometry, and so this is definitely mathy. There isn't going to be a calculator that does this because there's not much calculation to do, but you have to understand it. If you understand it, the math is really simple, but to understand it is tough. And then the mathiest question of all will be the next question. Whoops. And that is find the first quartile for the time that students spend with a math tutor. So what does it mean to be a first quartile? And while you're thinking about it, I'm going to copy and paste this guy. What does it mean to be a first quartile in the first quartile? And remember, that's part of your project, by the way, so you need to know this. First quartile. Remember, that means 25% is less than you. That was first quartile. So I'm going to modify this picture. I'm going to draw in a line, which we don't know exactly where it is, but somewhere like that. And we don't know what value that is. So when you don't know it, you give it a letter. I'm going to give it X, make it look mathy. But we do know that the probability of being between 10 and X is 0.25. Any questions on this picture? Okay, so now I just remember area is equal to base times height. What's the area of this left part of the rectangle? Not a trick question, it's very easy. Just look at it. What's the area of the left part of the rectangle? Of this piece?
Still 1.
No, 1 is the whole thing. 1 is all of this.
5.
0.25. That's why I labeled this. So the area of this left part of the rectangle is 0.25. And that is equal to base. Well, how do I find the base of this left part of the rectangle? How far is it from here to here? And I'm not looking for a number, I'm looking for an expression. If you're going from 10 to X, how far have you gone? I'm not hearing you all say it. What if I told you you're going from 10 to 50? How far have you gone?
40.
40. How'd you get 40?
Minus 10.
Right. Well, instead of that 50, it's going to be X. So the base is X minus 10. The height is still 1 over 110. Any questions on that? All right, so now we can multiply left and right by 110, and you get 0.25 times 110 is equal to X minus 10. And if we want to solve for X, what do we want to do to both sides? Want to get X by itself? What do we do? Yeah, how do we get X by itself? We have an X minus 10. Yeah, we add 10 to both sides. And if you add 10 to both sides, we get X is equal to 0.25 times 110 plus 10. Any questions on that? And that's what, 37.5 if I did in my head right? You can use a calculator. Yeah, I think that's right. Any questions at all on this example? Okay, I'm going to skip all these others because we don't have time to do everything. But I want to get to the next theorem and the last theorem of the day, or last big piece of new stuff. And that is, if X is uniformly distributed between A and B, then the mean is A plus B over 2. Why is that not a surprise at all? Why is that obvious just from looking at the picture? Okay, if you take two numbers, add them up and divide by 2, what are you getting?
The average.
The average. So it makes sense that the average is going to be the average of the left and the right, because that'll give you the center, right? On the other hand, sigma equals the square root of b minus a squared over 12. I don't expect anyone to look at that and say, oh, of course, that's what I was thinking. I would be shocked if that's what you were thinking if I asked you what was the standard deviation. But here's the formula. You can get that on your note card. You don't have to memorize it, but you have to know how to use it. So let's use it. So here's an example. Suppose that the number of ounces of water that people drink from the drinking fountain is uniformly distributed between 1 and 8 ounces, and that the number of ounces of water that students use to fill their bottles in the drinking fountain is uniformly distributed between 4 and 16 ounces. Okay, you watch Thorne take a 2.5 ounce drink out of a drinking fountain, and Preston fills his water bottle with 5 ounces of water before he runs off to class. Whose water usage is more unusually small compared to the rest of the people who use a fountain for the corresponding water usage? How do you decide how unusual something is? You remember doing that in this class, like 2 weeks ago? What statistic tells you how unusual something is? Here's a hint. It's very late in the alphabet.
Z-score.
The z-score. So the z-score tells you how unusual something is. Is that clear? So we need to find the z-score. And z-score is because there's two different things going on here. So then you got to remember the equation for the z-score. So z is equal to x minus, I'll make this bigger in a bit, mu over sigma. Any questions on that? Okay, so first let's look at these two. So we have Thorne. Okay, and Thorne takes a 2.5 ounce drink out of the drinking fountain. Okay, well, from drinking out of a drinking fountain, X is uniformly distributed between 1 and 8 ounces. Any questions on that? So what is mu? Well, I just use the formula. Mu is A plus B, 1 plus 8 over 2. And that's 4.5. And then sigma is equal to the square root of the fraction of 8 minus 1 squared all over 12. And that, let me pop that in the calculator, is about 2.02. Any questions on that? All right, so now I need to find the z-score. So I'm just going to copy and paste and put in what I need. So Thorn drank 2.5 ounces. The mean for drinking is 4.5. The standard deviation is 2.02. Any questions so far? And that is, it's about negative 1. Any questions on that? Okay, now I got to do the same thing for Preston. And by the way, Thorn and Preston were my students some years back, so I figured I'd use their names. So let's go for Preston. Now Preston is filling the bottle. And for filling the bottle, it's uniformly distributed between 4 and 16 ounces. So mu now is going to be 4 plus 16 over 2. And that's 10. And sigma now will be 16 minus 4 squared. Oops. Let's try that again. All over 12. And that is going to be, turns out to be root 12, but let's write down what root 12 is. 3.46. So now the z-score for Preston. Preston filled his wallet with 5 ounces. And the mean was 10. Standard deviation was 3.46. That gives you negative 5 over 3.46. Which is about negative 1.45. Any questions so far before I finish it off? Okay, so the question is, whose water usage was more unusually small? After doing all the work. Should just be able to look at it and answer the question.
Preston.
Yeah, Preston's. Yeah, Preston's was more unusually small because Preston is farther away from 0 on the left side. Since negative 1.445 is less than negative 1, Preston's water usage was more unusually small. Any questions on answering this question? Okay, so notice we needed to know the standard deviation and the mean. So those formulas were necessary. Without those formulas, good luck. All right, what I want to show you next. What haven't I shown you yet? The secret word. Okay, and actually the secret word is not truly a word. It's BH. Okay, why do you think it's BH today?
Base times height.
Yeah, base times height. So very important whenever you're doing a uniform distribution probability question, then you're always going to use A equals BH because it's a rectangle. So I always try and, give you something that you'll look at and you say, oh yeah, I remember that was a secret word. I got to use that. So that's the secret word for today. So we now understand uniform distributions, hopefully. And I want to mention next week we'll do the distribution, the most important distribution by far of any distribution in statistics. And what is that? I've mentioned it once today. Any thoughts? Normal. The normal distribution is a biggie. So after this week, we're actually going to spend 2 chapters on the normal, just focusing on the normal distribution. The first chapter is getting probabilities and ideas from the normal distribution. And the second chapter is to realize why the normal distribution is so important. So we're going to spend 2 full chapters just on that. So any questions? I'm kind of done with what I needed to talk about. So I'm going to stop the share. And I'm also going to stop the recording.